By now, you know the entire universe is made of something called energy, what the ancients called chi, the power to make something happen. Or, like Western science says, the ability to do work. And that most energy on Earth is contained in little teeny balanced systems of energy known as atoms, with negatively charged energy particles on the outside, electrons, and positively charged energy on the inside, protons, held by the balancing force of neutrally charged energy particles, neutrons, what the ancients call the yin and the yang, the balance of opposing energies that make up all of the material universe, varying in size depending on how much energy is contained. But how do atoms bond? Well, it has everything to do with the electrons. So let's map it out. I'll give you the atom. Let's start with lithium. Lithium has an atomic number of 3, which means it has 3 positively charged energy particles or protons in the nucleus, in the middle, which means it also starts out with the same equal and opposite energy particles orbiting around it, electrons. So let's use the electron configuration map to plot out how a lithium atom would look. Here's the first electron, here's the second electron, and here's the third electron, balancing out the 3 protons in the nucleus. But we have a little problem. See, the third electron right here in the P shell doesn't have a partner on the other side. Now, electrons love balance, which means you have 3 protons in the middle, but eventually one of those electrons are going to want to leave to restore balance to the lithium atom. And when that electron leaves, well, then it'll only be 3 protons to 2 electrons. See, that's why lithium is typically found with a positive charge or a +1 charge, because it'll want to lose an electron for balance. Now let's do the electron configuration chart for hydrogen. See, hydrogen has an atomic number of 1 proton in the middle, which means it has 1 electron orbiting around it. But problem, that 1 electron doesn't have a partner on the other side. And remember, electrons love balance. So let's put them together. You have a lithium atom that will want to lose an electron, and you'll have a hydrogen atom that will want to gain an electron. So if they're put together, they're going to want to bond. And that's what makes the very toxic and highly flammable lithium hydride. Check it out. Acute exposure to lithium hydride may result in irritation and burning of the skin or eyes or mucous membranes, increased salivation, and even difficulty swallowing, even spontaneous vomiting. So why do we even make it? Well, it's used as a conductor in chemical processes, but you have to handle it very, very carefully. And that's all because lithium and hydrogen have what each other needs. Now let's look at the oxygen atom. Oxygen has an atomic number of 8 protons in its nucleus, which means it starts off with 8 electrons orbiting around it. But problem, when that happens, you have 2 missing spots in its outermost shell. But if oxygen happens to be around 2 hydrogens, guess what? Those hydrogens have the electrons it's looking for, and therefore those 3 atoms will bond easily. And they do, plentifully all across the earth, and that's how we make H2O, water. Now, an easier way to understand which atoms will bond with each other is looking at the periodic table of ions. If you notice, on the left-hand side are atoms that usually want to lose an electron, thus gaining a positive charge. And on the right side of the table, we have atoms that want to gain an electron, thus gaining a negative charge. Why don't you take a look at it and see which atoms would want to bond with another? All you have to do is look at their charges. If one atom has what the other one needs, then if you put them together, they'll likely bond. Go ahead and try the electron configuration activity to see for yourself how atoms bond.